This is the final lecture in this series of teaching calculus to kids. If you have not watched the previous videos, there are two of them. Please pause this, view them, and come back. And this tutorial is for parents and teachers who wish to expose their kids to the basics of calculus. You do not need to have prior background in this to be able to enjoy this and teach your wards. So calculus is often taught as an extension of arithmetic or algebra. Unfortunately, it's not. So Newton and Leibniz, who invented calculus, they invented it because there were things they could not do in arithmetic or algebra. So in this video, I will show you how you teach calculus without resorting to arithmetic or algebra first. So here is a mind map of calculus. So there are three foundations of calculus. One is concept of function. Another is a rate of change. And third is creating diagram. There will be some instances of calculus when you don't need to be able to create diagrams. But in the beginning, it helps to think in pictures. And later, your ward, your kid, will go on to study many other things in calculus, limits, continuity, differentiation, etc., etc. But the concept of function, rate of change, and creating diagrams are the keys to understand. So we will go and look at this example, and this example will allow me to give you example of function, diagramming, and rate of change all into one. So what we have here is a hill, and it's a hill, and you can walk across and reach the top. So let me copy this picture and paste it in this so that I can write on this. All right. So what we have in this picture is that a person standing here, he wants to reach the top and say the top is here. So he or she will most likely will take this path like this. So we will study the concept of function, rate of change, using this example of walking up a hill. So this picture, let me draw like this, and the person starts from here, and here is the peak, and so what we have here, this is the vertical climb. And this is horizontal distance. So, though the person is walking along this, he or she is actually covering two types of distances. One, horizontal. So in this picture, it's here and here. So this person had the option of walking along this, or what the person could have done, first gone this distance and say this is 200 meters, and let me draw this. Suppose this is 100 meters. So what this person could have also done, that walked 200 meters in this direction and then climbed in this direction 100 meters. But we don't do that because walking along a slope is far easier than climbing up here. So this person, in the process of covering 200 meters in the horizontal direction, also covered 100 meters in the vertical direction. So now let me take a segment. So let me draw here a segment. And also okay. So let's call this, we use a variable and I call it h. So as the person walked h along this, so let me use a different color to mark. So on this hillside, I'm talking about the person moving from here to here. So when the person walked h along the side of the hill, he or she covered this in the B direction, in the horizontal direction, and P in the perpendicular direction or vertical direction. So we don't pay attention to this, that as you're walking along a side of a hill, you are actually moving in horizontal direction as well as vertical direction. And and imagine we have another point. Let me draw it here. And I call this B prime, and this is P prime. So as you see that B prime is bigger than B, and as a result P prime is bigger than P. So the function here is that vertical climb depends upon horizontal distance. So I come here, and at this time I will introduce a notation here. I like yellow. Let me go back to yellow. So what I wrote, vertical climb is a function of horizontal distance, or P is a function of B, or we can write P F B. So the relationship between P and B is this. If B increases, this implies that P also increases. That means if you move in this direction, that means you also move in this direction. And that happens because of the way you walk over a hill. So what we did, we showed you that perpendicular distance is a function of horizontal and the change. So change in horizontal distance leads to change in vertical climb. And for a given scenario of, say, a mountain like this, you can predict that if the change, and I'm putting another notation, is called a delta. So if you know delta in the horizontal direction, you can guess delta in the vertical direction. So you see, we are not using any formula. we are driving home the concept of how two things can be related. So now let me go back to my presentation and bring another picture. So look at this picture and I will take it to my blackboard. All right. So this is another hill, and here is the line up almost. So I'm drawing the horizontal distance and the vertical distance. And let me draw something close to that. Here, let me draw. All right. So once again, as a person is moving in this direction, he or she is moving in horizontal as well as vertical direction. So when the person moves from here to here, in the process also climbs this. Now, I ask you this question. Which will be easier to climb? This hill or this hill? So the difference between these two pictures is this, that distance in horizontal direction increases, then perpendicular also increases the distance in the vertical direction. But the rate of change, so I call it delta B, change in this direction, and corresponding change in vertical direction is this. So that's delta P. So if we compare this picture and this picture, what we can see in the second case, change in the vertical distance is slower in the second case. So the rate of change in this case is slower compared to this case. So it is easier to climb or walk up a hill which looks like this compared to a hill that looks like this. And The difference that makes is this, the angle, and we call it slope. So this is slope 1, and this angle I call slope 2. So it is clear that slope 1 is larger than slope 2. So let me write it here. Slope 1 is greater than slope 2. So this implies that in the case of slope 1, the change in vertical distance is faster with change in horizontal distance, which is delta B. In both the cases, as you move in the horizontal direction, you gain height. But because the slope of 1 is larger than the slope in the case of 2, you gain height slowly. So now let me show you another picture, which is here. So this is a very steep rock for rock climbing. And imagine that you have to move. You want to climb up. So this is a nearly vertical climb. So let me draw it here. I put the axis here, and this is the peak of this hill. So in this case, the slope is this. So in this case, slope is larger than even this, the case of the first mountain. So as a result, what happens, the change in the vertical direction happens with no change in the horizontal direction. So this is also a kind of function that P is a function of B, but B remains constant or 0 in this case. So let's go back to our mind map. I had talked about that calculus has got 3 key concepts. Concept of function. So here, what we have been trying to understand, that when we move in the horizontal direction, how the vertical direction changes. So we saw that in this case it's a steep slope, so vertical direction changes, vertical distance changes a lot as we move in the horizontal direction. In this case less, and in this case it's really steep, you go vertically up. So what you can say, by looking at the slope, you can guess the rate of change. So you will say that, hey, this slope is larger than this slope, so walking up this hill will be easier in the, let me write here, second case compared to the first case. So you do not need to know calculus to able to make this judgment, because we know it from experience that, but now you can explain this in the language of calculus, which is by creating a diagram and looking at rate of change. Now we are taking a different example. It's a route of a train. So a train goes through stations, and this is for the first train. So this is train 1, and this is train 2. And here is the plot. We have time going in this direction and distance. Let me take a little darker pen. Distance in this direction. So going back to the our goal, concept of function. So let's see how concept of function applies in this. We see that distance is a function of time. So you see here, as we go from starting to 5 hours to 10 hours to 27 or 17 hours, we cover distance. We also move in this direction. That means we cover distance is a function of time. Now I have two plots. So this plot is for train 1, and this is for, let me take a darker pen. Okay, so this is for train 1 and this is for train 2. So you see that the slope here is for train 2, and let me draw a line that makes it somewhat straight line here, and then okay, so this is slope 2 and this is slope 1. So it is very clear that slope 1 is greater than slope 2. So if somebody showed you this graph and you see that slope 1 is bigger than slope 2, you will know this is the distance, that the larger slope covers the same distance in a shorter time. So the first one is 17.55 and the second one is 27.55. So the second one that has got smaller slope, that means it's slower than the first one. So let's take an identical slope of a slice of time. So I'm drawing this. So this is, so I call it T1 and this is T2. And I draw this line here on the second. Let me use a different pen, red. So this time is T2 minus T1, and I call this one D2 and this is D1. So D1 and D2, this slope and this slope. So because slope 2 is greater than, slope 1 is greater than slope 2, D1 is greater than D2. So in the same time, T1 minus T2, the first train covers more distance than the second train because the slope is of the first train is bigger. So we saw what rate of change looks like. All right. So once you understand this, once your child understands this, next is limits, then continuity, then differentiation, then integration. They all become easy once you understand these basic concepts. All right. Thank you. And I look forward to your feedback. Here is my email address if you want to write to me. Good luck.